Welcome to today's video, where we're going to dive into the fascinating world of building design. Specifically, we'll be taking a closer look at the process of designing the structural elements of a building, from identifying the primary and secondary elements to considering different framing options and the advantages and disadvantages of two versus three-dimensional modeling. So, let's start at the beginning. When designing a building structure, the first step is to identify the primary and secondary structural elements that transfer loads to the foundation and any constraints on the building's form. This is a critical step because it sets the foundation for the entire design process. Now, the designer's objective is to create a safe and cost-effective structure within the constraints of the project's specifications and architectural requirements. To achieve this, the designer needs to consider different forms of framing to find the most economical solution, with pinned connections being the most affordable. But the designer shouldn't just stop there. They should also consider simple construction with braced frames and pinned connections as the preferred option, followed by rigid frames in one direction with ties and bracing, and rigid frames in two directions. It's important to note that there are usually multiple options for the form of the building frame. Moving on to modeling, two-dimensional models have several advantages, including simplicity in analysis and output, greater rationalization in member and connection design, and practical benefits during fabrication. Therefore, a two-dimensional frame with simple ties in the other plane is recommended for economical fabrication. Now, in cases where vertical bracing is not allowed in every transverse frame, one solution is to model the transverse frames as rigid, but it may be possible to provide bracing on the longitudinal elevations. This allows the structure to be modeled as a rigid frame in the transverse direction, with ties and bracing in the longitudinal elevation. If bracing cannot be accommodated, discrete rigid frames can be provided in one or more bays to resist the longitudinal forces, and the structure would still be modeled as rigid only in the transverse direction, with a separate model for the rigid frames on the elevations. When it comes to three-dimensional modeling, it's a useful tool for complex structures, but brings additional problems and complexity that can lead to mistakes. For orthodox structures, which consist of two series of frames at approximately right angles, two-dimensional modeling is usually satisfactory and recommended. However, the cost of the local stiffening required to achieve rigid connections in reality must be considered when choosing between two- and three-dimensional models. Moving on to the process of decomposition, or the transformation of a real structure into a plane frame model for analysis. The primary, secondary, and other elements of the structure are identified, and planar and secondary elements are eliminated from the model. Load parts are carefully considered to ensure that out-of-plane loads are included in the analysis of the plane frame. Even though secondary elements are eliminated for analysis, their restraint may be utilized during member design. In two-dimensional modeling, it's generally assumed that out-of-plane members do not produce biaxial bending or torsional effects in the primary frame, and actual connections should be nominally pinned to minimize out-of-plane effects. However, in some cases, bending effects from out-of-plane members must be included in the analysis or at the design stage. Finally, the majority of steelwork structures can be effectively analyzed as two-dimensional models, with the exception of some specialized structures. Two-dimensional modeling is recommended for its simplicity, as well as the ability to replicate frames in real life, which leads to greater economy in analysis, design, and fabrication. Connections to out-of-plane members are typically nominal pins to prevent complex and stiffened connections. Standard profiles are primarily designed to bend about one axis. We hope this video has helped you understand the process of designing a building structure and the different forms of framing to consider. Thank you for watching.